This video is for Math 0242-1342. We are starting chapter 10 here with sections 10.1 and 10.2. This homework assignment in ALEKS was supposed to be 9.3, 9.4, 10.1, and 10.2 all together. And it turned out only the first 7 problems in here were from chapter 9 and the last 8 are from chapter 10. And when I was doing the last video, I wasn't even paying attention when the sections ended. So we did too many problems last time in terms of stopping when we were supposed to. So we covered 1 through 7. I think I did 8, 9, and 10 already too. But just to review what this was supposed to be about, 7 was a hypothesis test about proportions. So then 8, it clearly switched to two means, and we're doing a confidence interval for 2 means. So it's not even about proportions, and it switched from 1 sample to 2. So we're trying to do a difference between means, confidence interval with 2 answer blanks here. There's a group of 70 people enrolled in a weight loss program where they get a special diet added to exercise, and then they lose 24 pounds on average with a sample standard deviation of 9. A second group of people went on the diet, but they didn't exercise, and it seems like on the sample information anyway, that the group with exercise seemed to lose more pounds significantly than those who didn't, but you can never tell just by the raw data alone. So because we have sample standard deviations, this is stat. You can see it better, maybe not. Press stat, go over to tests. The first 6 are all for when you're doing hypothesis tests when they have the 5-step process. But when you do 7, 8, 9, 10, 11, and 12, these are all confidence intervals. And we're doing means, so means are definitely Z or T, and definitely 2 sample. And since we know sample standard deviation, then it's 2 sample T intervals. And you could do data if you had all the raw data, but usually it's stats. Okay, so the first sample mean was this 24-pound weight loss. For the first sample of 7 people, their mean weight loss was 24. So the first sample average was 24. With a sample standard deviation of 9. So clearly that's marked sample standard deviation. That's definitely S. There was a group of 70 people in the first sample. And then the second sample average was only 13 instead of 24. See, that seems it's almost half of it. So that seems to be a significant difference. 13. This sample standard deviation is 8, and it was a group of 45 people. So 8 and 45. And then how much of a confidence level are we doing here? Construct a 99.9% confidence interval, 99.9. So C level is 0.999. And then pooled no or yes, but this one's always no. Calculate. 5.5576, 16.442. And both of those answers are positive is another significant thing about the answer. If both answers are positive, that means the first population is greater than the second population on average. Round to the nearest integer. So the 5.55 is going to round up to 6. And the 16.4 is going to stay 16. So we think the difference in the means is between 6 and 16. So that means the group that got the exercise, they're losing on average between 6 and 16 more pounds than the other group. And that's all positive, so that means they're significantly above the other one. They're losing more weight by also exercising. So there's only this one part here, but sometimes they ask you to do a second part where you're looking to see if the interval you got contains 0 or not. If it contains 0, if the first answer is negative and the second answer is positive, then you can't tell which of the original populations is larger. It could be either one. But if both answers are positive, then the first population is definitely bigger than the second. If they were both negative, then you would know the second population would be bigger than the first. So since the first population is bigger, since both answers are positive, that means doing diet and exercise is going to lead to more weight loss, a larger weight loss than the group that only does the diet. So then they could use that as evidence for arguing what they want. This is the example of data. So there's one of these in the homework every so often just to show you how it really works. So we did that one already. So let's do another one of these that are data and not, that are stats and not data. And this time it does have the two parts to it. So there's a survey of college students. They reported in a sample of 413 male college students. The average number of energy drinks consumed per month was 2.44. Now this time it only says with a standard deviation of 4.78. But even though it doesn't say population or sample standard deviation, this is a sample standard deviation because it came right in the same sentence when they're talking about this sample of 413 college students. Then there's a sample of 366 female college students, and their average was 1.73 with a standard deviation of 3.31. So that means that's another sample standard deviation there. And we're trying to do the difference in means for a confidence interval, 99.8% confidence interval for the difference between the men and the women. So this is exactly the same kind here. 2 sample t interval. Stat, tests, number, what would be 10, but they call it 0. Same deal. So there's a sample mean for the men. The men's sample mean is 2.44. 2.44. Whoops, didn't get the point. 2.44 with a standard deviation of 4.78. That's S. 4.78. There was a sample size of 413 males. And then the second average for the women was 1.73 compared to this 2.44. So the 2.44 seems to be higher, but maybe it's not significantly higher. 1.73. Whoops, too many threes. Okay. S, the second standard deviation was 3.31. And then they had 300 and something in their sample size, 366. And this time instead of a 99.9, it's 99.8. So in here, that's 0.998. And just hit no for pooled every time. Calculate. For some reason, the t takes longer than proportions or z's take. But see, right away, I notice there's a negative first and a positive second. So that means even though the men were higher in the sample, it's not significantly higher. And I can't say that the men or the women are higher than the other because 0 is in this interval. And if the difference is 0, that means they're the same as each other. So because 0 is in this interval, that means 0 is a possibility, and that means the men and the women could be equal, even though the men's average was what's seemed higher, but it's just a little bit higher is what that's saying. So they say round to 2 decimal places each. And it was negative 0.1956. I'm going to make that negative 0.20. Instead of negative 0.19, I'm making it negative 0.20 because the next digit's a 5. And then it was 1.61, but after that was a 5, so 1.62. So if you take the men's average minus the women's average, if the answer to that would be 0, then that would mean the two groups are equal to each other. And since 0's in this interval, then it's a possibility that they could be equal. Based on this confidence interval, is it reasonable to believe that the mean number of energy drinks consumed may be the same? See, based on this confidence interval, it may be the same. That is true, actually. It could be the same because 0's in there. It is reasonable to believe that it could be the same for both because 0's in the interval. And when a difference is 0, you only get a difference of 0 when both numbers you're subtracting are the same. So I know we did 8, 9, and 10 in the last video, but at least you got to see 8 and 10 a second time now. And I can't remember if we did this one or not, but see, this is the same kind of problem where they just run it for you rather than making you do it in the calculator. They're just having here's the calculator information right here. Somebody ran a 2-sample t interval. The first answer was 20.9 and the second one was 74.1, but they're both positive. 0's not in this interval. So whatever the first average is, 150, that is significantly bigger than the second average of 102. So the point estimate is when normally a point estimate for one population problems is whatever the sample mean or sample proportion or sample standard deviation is. Since we have 2 sample averages here, and we're trying to do mu1 minus mu2, well, the point estimate would be x bar 1 minus x bar 2. So I could just simply take the 150.375 and subtract 102.856. So in the sample means, there's a difference of 47.519. That's the point estimate. The point estimate is like one chance to get this prediction right. How many degrees of freedom did the calculator use? It's right there, 12 point, and I'm not sure if they want it rounded. It doesn't say, so I'm going to put the whole thing. 12.28537.157. We normally, when we do these things by hand, you normally don't get a decimal amount of degrees of freedom, but it's using some complicated formula and equation, so if whatever it comes out, we can just, since this was provided for us, we can use that. 12.28537 12.28537 157. We are 95% confident that the difference between the means is between blank and blank, so that would be the two confidence interval answers. 20.904, 20.904, and 74.134. And they're not asking to interpret it because we don't have the whole problem in front of us. This is all about reading technology and being able to do it that way. But because both of these answers are positive, that means the first population is significantly larger than the second population, since the difference is positive. For sure it's positive because we're predicting it's somewhere between 20 and 74. Okay, so now mean difference. So remember when we had before and after problems in chapter 9? We did before and afters for the hypothesis testing. So now this is like before and after for a confidence interval. So 2 microprocessors are compared on a sample of 6 to determine whether there's a difference in the speed. So it's kind of like processor A is the before and processor B is the after. If you remember how we did those, you put the befores in L1 and the afters in L2. So I'm going to go to Stat, and then while it's on Edit, press Enter. And every time I come in here, it always is blank right away, but you probably still have data in here from previous problems. So clear it out first by going up to the top and hit clear enter. Then type in 27.2. Trying to do this so you can see it, so I don't have to hold the phone right next to the calculator. 27.2, and then press enter. 17.4, enter. 21.1 and 18.0. Let me check those two. 21.1 and 18, 26.4 and 27.5. Yep. So just 6 data points in L1. So now right arrow over to L2 and put these other 6 numbers in there. 24.2, 18.3, okay, 27.9, 27.8, 20, a couple of 26.1s, 26.1, 26.1. So this isn't really a before and after, but you can do it the same way it is as if it was a before and after. So when we have before and afters, then you go to L3 and you got to move up arrow to the top, hit the up arrow so L3 is actually highlighted. And then you want to hit second and the number 1 to get L1 minus second and the number 2. See how it says L1 minus L2 for L3 there. There's nothing in it yet, but as soon as I press enter, it'll do all 6 subtractions in a fraction of a second. So it just took 27.2 minus 24.2, which is literally 3. It did 17.4 minus 18.3, that's negative 0.9. So some of these differences are negative. There's 3 negatives and there's 3 positives. So that's usually what, if you're going to show that one of these is a significant difference compared to the other, then you should get like all positives or all negatives or maybe close to all of one or the other, or have some that are significant. Like the 2 of the negatives are pretty significantly negative, but everything else is pretty close to 0 actually. So the fact that there's half positive, half negative, we're probably going to have a case where 0 is a possibility, so then there isn't really much of a difference here. So when you're running a hypothesis test, a before and after hypothesis test for the mean difference, that's where you put you do the L1 and L2 before and after, subtract them in L3, and then you run a regular t-test as if you were doing a single set of data instead of 2 sets of data. So here what we're going to do is we're going to run a single z interval. Stat, go over to tests. See, t-test is what you use when you're doing a confidence, or when you're doing a hypothesis test for these before and afters. So instead I'm going to go down to number 8. Right there, t interval, which is supposed to be meant for one population, but I'm going to do it even with these 2, because this is the one time you're going to work in data for sure. You have to do data for problems like this. The other ones can be data, but this is the one time it has to be data no matter what. And then you want the list to be L3, not L1 that it defaults to. So press second and the number 3. Leave the frequency on 1, and then there should be a C level given to me here somewhere. Find a 99% confidence interval for the difference between the means. And because they put mu d, that's a giveaway that that's what this kind of problem is. It's not just a normal t interval. So 99% is 0.99. 0.99 for 99%. So calculate, and then we should get our interval again. See, one answer is negative, the other one's positive, so 0 is a possibility here. Negative 10.42, 2 decimals. Negative 10.42. Positive 6.1. I'm going to bump this 5 up to a 6 because there's a 7 after it. 6.16. Okay, so a computer scientist claims that the mean speed is the same for both. See, that is possible here because the interval contains 0. And if the answer is 0, then they are the same, but it's not a guarantee that it's the same, but it's a possibility. Does the confidence interval contradict this claim? No, it doesn't. The confidence interval almost agrees with it that 0 is a possibility. Because the confidence interval contains 0, it is possible that the claim is the same. It does not contradict it because it's possible. So these are like the before and afters we used to do when we were doing hypothesis testing, but you're doing it for a confidence interval instead. So here's apparently a similar case. So you're starting over again. Go to Stat. And while it's on Edit, press Enter. This takes you into the spreadsheet. Now you need to clear out list 1 and list 2, but turns out you don't have to clear out list 3. I can just zap over it. So I'm going to leave L3 alone. I'm going to go left arrow and up arrow to get to the top of L2. And while I'm at the top, if I hit clear, enter, then it clears that list out. You don't want to hit delete or the whole list disappears. So left arrow, up arrow so that L1 is highlighted. And then hit clear, enter. So now I'm all set to type in a new data set. In L1, I'm going to put 1375, 1366, 1367. Double check those three. 1375, 1366, 1367, yep. 1382 and 1359. 1382, 1359. Okay, there's L1 that was like a before. So then right arrow over to L2 and put in these other 5 numbers. 1336. Enter. 1315, enter. 1353, enter. 1336, 1315, 1353. 1354, enter. 1322, enter. Okay, see how the old data is still in L3, but I'm going to right arrow over to L3. I'm going to go all the way to the top, not there, but all the way to the top, L3. And if you tell it second L1, second 1 for L1 minus second and the number 2 for L2. And before I press enter, see at the bottom how it says L1 minus L2 in L3. Then press enter and it zaps over the old ones with the new data. And notice all these are positive, and some of them seem, a couple of them anyway seem so, most of them seem significantly positive. There's a 14, but there's a 20, a couple of 30s, a 50. So again, you can never tell alone from that, but it seems more likely that the first population seems greater than the second because all the subtractions are significantly positive. Okay, so now we can run our t interval. Stat, go over to tests and go down to what would be number 10. I'm sorry, 8. It's only, we're pretending that we just have one data set. So number 8, t interval. And this is definitely a time you want to be on data and not stats. And the key thing is the list needs to be L3. The frequency, I just keep that as a 1, and we're staying with 99% for the second time in a row. So down arrow to calculate and press enter. I'm betting both of these will be positive. Yeah, see 5.44. Oh, they want one decimal. 5.4. 5.4 and 62.2 because there's a 1.5 there, so 62.2. 62.2, and you can't see it because it's way over here. 62.2. But now the interval does not contain 0. Because the confidence interval does not contain 0, then it's not possible that these two things can be equal to each other. Then one of them, the first one, should be bigger than the second. A civil engineer claims that the mean strength of blocks cured 3 days is the same. Does the confidence interval contradict this? Yes, it does. It contradicts the claim. The claim says they're the same, but my confidence interval says they're not the same. Because it's all positive, that means the first one's actually bigger. Okay, so both 12 and 13 were similar kinds of problems. 14 and 15 might be similar too. We're still doing a confidence interval for a mean difference. And now this is, I guess, sort of like a before and after. First you rest, and they measure your breathing rates, and then you exercise and they measure them again. So that's definitely a before and after. So there's 10 subjects, 1 through 10, and that could be their names, so we're not going to use the 1 through 10. Put the rest data in L1 and put the exercise data in L2. And let's see if I put this here, if you can still see it. Yeah, okay. Stat, go down to, I want to do edit, so I'm going to go down and press enter. So here's a new problem with L1, L2, L3. So you can clear L3 out if it bothers you, but I only clear out list 1 and list 2. Clear enter. And now go over to list 1, go up to the top, clear enter. So now I'm ready to type the new data in, and don't put the subject numbers, just the rest and the exercise. So L1's going to get 15, 16, and 20. 15, 16, 20. 18, 14, 17. 18, 14, 17. 18 and 21. Whoopsie, that was a typo. 18, 21. No, it's supposed to be 18 and 21, not 18, 21. Sometimes when I push a button, it clicks, but it doesn't register somehow. Okay, 18 and 21, now it's correct. 19, enter, and 15, enter. There, we got all 10 of them. So now the exercise, then here the exercise numbers seem to be a lot bigger than the resting numbers, which makes sense. If you're resting, you don't breathe very much. As soon as you start exercising, you breathe more. So it clearly seems that the second number should be bigger than the first numbers. So what that means, when you subtract them, you'll be getting negatives though. 15 minus 30 is negative 15, and 16 minus 37 is negative 21. So now I'm guessing that the confidence interval will be all negatives probably, or significantly negatives. 30, 37, 32, 40, 30, 37, 32, 40, yep. Okay, 32, 31, and let's do 36 too. 32, 31, 36, yes. And the last three are 30, 34, and 37. And there should be an equal amount of data in both lists because it's the same people twice. And the numbers have to match up with each other. So the 15 has to be next to that 37. You don't want to sort these like from lowest to highest. Now notice L3 is still the data from the previous problem. That's okay. Go over to L3, up arrow, keep going all the way to the top right there where it's got L3. And if you hit second and the number 1 minus second and the number 2, it'll zap over the old ones. Second L1, so you can see right there at the bottom, minus second and the number 2, L1 minus L2. And there's nothing there now. This is old data still, but as soon as I hit enter, now it's zapped over them. And see how they're all negatives? Negative 15, negative 21, negative 12, negative 22, negative 18, negative 14, negative 18, negative 9, negative 15, negative 22. They're literally all negative. And you would definitely expect that because it's clear that you breathe more when you're exercising. So now do stat tests number 8. The T, we always do T interval because they never tell us sigma on problems like this, so it's never going to be a Z interval. And then press enter to select T interval. Keep it on data, keep it on L3, and keep it on 1. The 99% might change. No, it stayed the same, 99% again. So I don't even have to change anything here, just keep it all the same. Calculate. So they're both negative, negative 21.1. And negative 12.1. So on average, the difference is somewhere between negative 21 and negative 12. But more importantly, it's all negative. Okay, wait. I must have had a typo. Round to 1 decimal. There was no rounding at all involved. Okay, let's check it. $15, $16, $20, $18, $14, $17, $18, $21, $19, $15. Okay. $37, $34, $30, $36, $31, $32, $40, $32, $37. Huh, that's weird. Negative 15, 21, 12, 22, 18, 14, 18, 9. Yeah, they're all right. Stat. Oh, maybe there is a sigma here. I just assumed there wouldn't be. No, it still means, and there's no sigma given anywhere. It's clearly a mean difference. 99%. T interval for sure. L3 and 1. 0.99. Negative 21.1, negative 12.1. Huh, that's weird. Okay. I guess it's because I didn't read it closely enough. So rest is listed first and exercise is second, but maybe they're wording this backwards because I have the same answers, but mine are all negative and theirs are positive. So construct a 99% confidence interval for the mean increase in breathing rate due to exercise. See, increase, mean increase. So if you want to do a mean increase, that means you have to put the bigger numbers first. And let D represent the breathing rate after exercise minus the breathing rate. See how they worded it right here. D is the breathing rate after exercise minus the breathing rate at rest. They're doing the exercise minus the rest in that order. And they just gave it to me backwards in the chart. So you can get tricked by that because I just did. Let me see how these ones were worded. We had processor A, processor B, But see how this one stays the same. Let D represent the speed of processor A minus the speed of processor B. So usually it's in the order that the data is given to you. But I guess if you're not paying attention like I wasn't, you can get tricked by that. Here, the second problem was after 6 days and after 3 days. And let D represent the strength of 6 days minus 3 days. So the first two problems here were done in the order the data was given, but 14 tricked me. And luckily, if you were watching this video before you did this problem, then you can be saved and not make the same mistake I did. But yeah, they worded this backwards from the way it is here. So yeah, it was clear that maybe they did it because it was so clear that of course the rest is going to be smaller than the exercise, but if you do it backwards and do the exercise minus the rest, then it should be all positive. And notice my answers are the same, just positives instead. So based on the confidence interval, is it reasonable to believe that the mean increase is 20 breaths per minute? So now it's so obvious that there's an increase or decrease depending on the order you do this in. Clearly you breathe more while you're exercising, whether you consider that first or second. So because of that fact, they're not even bothering to worry about 0 at this point. It was clearly never going to be 0. So 20. Now they can just give you a number like 20, but 20 is in the interval. So is it reasonable to believe that the mean increase is 20? That is reasonable to believe because 20 is in the interval. So instead of trying to compare 0 to the interval, it can be some other random number that they just give you. The confidence interval does contain 20. So it is reasonable that the claim could be true. The confidence interval does not contradict it. It doesn't prove that it's right, but it doesn't contradict it either, is why they're wording it that way. Because you always assume the null to be true. You can't prove the null to be true. So yeah, I'm going to have to, when we do this lesson, I'm going to do it a little slower and make sure I read what the order in the question is compared to the order that the data is given. So 15, here's the classic before and after that we normally do. So I'm going to put you can still put them in the order they come, but you might have to do it backwards then. Okay, so I'm going to go stat, enter. I'm only going to clear out list 1 and list 2. Clear, enter. Clear, enter. Okay, the befores go in L1, 178, 180, 177, 174, 175. Go over to L2, put the afters, 139, 126, 142, 141, 143. We don't put the subject numbers in. Those could be people's names for all we care. Okay, so now I got to read this and make sure there's nothing different about the order here. Construct a 90%, they are changing the 90 this time, 90% confidence interval for the mean reduction in cholesterol level. This part here is the important part. Let D represent the cholesterol level before the new drug minus the after. Okay, see, that's the correct order. Before minus after, but I didn't realize you need to read that closely because they had one tricky one in there. But usually it's the same order that they come in the chart, but there was one that they tricked me anyway. So L1 minus L2. See, they're all significantly positive too. So that means your cholesterol level, when the first number is bigger than the second one, 178 is bigger than 139, 180 is bigger than 126. When the first number is bigger, then when you subtract, that's how you get a positive answer. And in cholesterol, you want to lower your cholesterol level so that whatever they're doing to these people, drug or exercise or whatever it is, it seems to be helping because every single person's gone down significantly, seemingly significantly, because they've all gone down 30 to 50 points in their cholesterol level. That seems to be a significant difference. So stat, tests, and number 8, T interval, and keep it on data, L3, 1, And I got to change this to 90%, 0.90. Calculate. Round to 1 decimal place. 30.0, 47.2. This 1 will get bumped up to a 2. 30.0 and 47.2. So could you get your cholesterol to be reduced by 50 milligrams? So that maybe this is just somebody who's a little gung-ho and they're like, boy, our medicine really works well. You should take it and you'll really lower your blood pressure or your cholesterol level by 50 milligrams. So that people over-exaggerate sometimes on claims. And there is what seems like a significant reduction, but not quite this much. So the confidence interval does not contain 50 this time. That's a little too high of a claim. It does contradict the claim that you could reduce your cholesterol by 50 points because 50 is not in that interval. Now, what I could have done on 14, let me try another one here. Here's what we could have done on 14 if I typed all the data in first before I realized it was worded backwards. So you just get to a problem and you're kind of just blindly putting them in here the way they come. Let me clear out list 2 and list 1. So I'll put the list 1 numbers in again: 16, 19, 14, 17, 15, 19, 20, 17, 21, 16. There's all 10 of them. Then I go to the exercise numbers: L2, 30, 35, 39, 31, 36, 36, 40, another 40, 38, and 34. So say you did that, and then you go to this question here, and it says, find a 95% confidence interval for the mean in breathing rate due to exercise. And then when it says let D represent the breathing rate after exercise minus the breathing rate at rest. And you're like, oh, it's exercise minus rest. But I did rest first and exercise second. You don't have to delete and switch everything. You can just go to L3, go up to the top. I could type in L2 minus L1 just to match their wording, the way they're wording this, of exercise minus rest, and exercise is L2 and rest is L1. So if I did it that way, then all the answers are significantly positive rather than significantly negative. And then I could still run stat test number 8 T interval and just leave all this the same, except for the C level needs to be 0.95 this time. This is what I should have checked when I got it wrong. I should have read the question instead of just assuming. I thought I had a typo, or maybe that it was just completely wrong, but then when I saw the answers were the same, just positive, then I knew they were doing it backwards. So now we want how many decimals? 1 decimal. 15.86 would round to 15.9. And 21.13 will stay 21.1. And this time I got it right the second time around. So they want to know, is 20 a possible value that could happen? And 20 is a possible value because it's between 15.9 and 21.1. So the confidence interval does contain 20. So it does not contradict the claim that it could be 20. Does not contradict the claim. Okay, so now I got green checks on every problem that I did here. So the first video of this unit was supposed to be problems 1 through 7 only, and I was going way past that, not paying attention to that. This is, see, I'm trying to keep the assignments to be, so there's only 20 of them, so they each count 5% of your grade. So when we got closer to the end of the whole semester, I had to like group some more sections together like this: 9-3, 9-4, 10-1, and 10-2. So 1 through 7 was 9-3 and 9-4, and then 8 through 15 was 10-1 and 10-2. So we actually did 8 and 10 twice, and 9 I did in the other video. So and 9's like 8 and 10, except you just do it with data instead of stats. So every problem's been done once, and 2 problems have been done twice. And I need to give you a magic word of this video too. Let me just show you in here. See how it's section 9-3, 9-4, 10-1, and 10-2. That's the first assignment, but it took 2 videos to cover all that. So there'll be a third video that's going to be 10-3, 11-1, and 11-2 that'll cover this whole assignment in one video. The fourth video will do 11-3, 12-1, and 12-2 all in one video. And then the fifth and final video for this unit will be the review as usual. So the magic word of the second video, the second magic word of Unit 4 is, we'll keep the same theme as the first one, but let's go back to the month of May. M-A-Y. The month of May is the second magic word of Unit 4. I think when I recorded the first video, I hadn't created the review or the test yet, but they're here now. So every assignment for the whole semester is almost here now. There's only 2 things missing. I had to create all these from scratch when this semester started, so there was no way I could get them all done at the start of the semester. I usually have them all ready for the whole semester when, like if I get another 1342 class next semester, I can just copy all these assignments for the next semester. But this was the first, we just switched to this textbook this semester. We used a different publisher even before. So I had to just create every homework, every review, every test completely from scratch. And so since the first video ended and I recorded the second video, there's now a review and a test for chapters 9 through 12. It's not all of all those chapters either, because it's just the sections we do. It's only 9-3, 9-4, 10-1 through 3, 11-1 through 3, and 12-1 and 12-2. It's 10 total sections basically. And we're missing 2 things here. We don't have the review for the final or the final exam itself, but they'll be coming soon as well. Certainly before you take test 4, you'll see the review for the final and the final exam eventually here. So this video was a little shorter than usual, but that's just because I had to break this one, a longer assignment, up into 2 parts. The next 2 videos should be the usual amount of time probably to get through all those, because they're usually 15 problems each. Oh, this one's only got 12, and then this one's got 10, but some of these take longer because they're like the 5-step process. And then the review's got 20. Okay, so that's it for video number 2. Send me the magic word once you get a chance.